Hello friend, this is Steve B, and on today's video we are going to configure a RIP protocol in Cisco Packet Tracer. First, let's have an understanding of what RIP stands for. RIP stands for Router Information Protocol. It is an older simple distance vector routing protocol used by routers to exchange network path information, choosing the best route based on fewest hops or routers to pass through, with a limit of 15 hops, making it best only for small networks. Routers periodically send their entire routing tables, usually every 30 seconds, to their neighbors, allowing dynamic updates and route discovery, but its low convergence and hop limit makes it less efficient for complex networks compared to protocols like OSPF. Having said that, let's proceed to design our network topology and do the practical session lab. Thank you. So what I'll do, I will just add routers. First router, and add another router, and then I will also include switch and another switch, and then add some end device to this topology. We'll have a PC and a laptop for the first network. We'll use a server and a laptop for this other network. So in our topology we have a total of 3 networks, but before I note them down, let me first connect our devices. So I will go with automatic cable selection for purposes of saving time. But what you need to know is that for similar devices you go with crossover cables, and for the similar devices use a straight through cable. That's very important. And in our topology, the dotted one stands or resembles a crossover, but the continuous black line, it's for the straight through cable. Or we can try to actually just demonstrate how. So you select the port just like that. So let me now note down the network address that we are going to use for this. Okay, let me note down the network address that we're going to use. So for the first network I'll use 192.168.10.0, the format .10.0. Then the second network is the network in between the two routers. I'll use 192.168.20.0, and the final network is 192.168.30.0. So the next step to take is to assign IP address to our end devices, since we do not have DHCP configured. So on this PC2 we have to assign IP address 192.168.10.2, and also you have to assign a default gateway that will give us access to the router .10.1. So you can just copy this address, paste and edit in the next end device. Copy. Then on this PC, on this laptop, just paste your address and edit it to, let's say, 3. and then also with the default gateway, and we are done with the first network and devices. So let's assign IP address to the last network and devices. So we are done with assigning of IP address to our end devices. The next thing to do, we are going to open our routers and then assign IP address to the interfaces to the router. So I'll use the CLI or the command line interface. Just type no, and then you type enable to get to privilege mode, and then configure terminal to get to global configuration mode. So we can decide to name it host name, router sales, router underscore, because we cannot have space, underscore sales, and so on the interface, which will serve as our default gateway, that is interface giga ethernet 000. We add an IP address 192.168.10.1, then include the default gateway, not the default gateway but the subnet mask 255.255.255.0, and then to power it on you just use the command no shutdown, but if you type no shut, still it will power on. And then on the other interface, that is interface G001 IP add (192.168.20.2). You include the subnet mask 255.255.255.0. You can use the command no shut, and then you do the same to this other router using the CLI. No, enable, configure terminal, and you realize that I just pressed conf t and actually the command ran, and you could be wondering, Steve B, why do you type conf t instead of configure terminal and it actually runs? That because there is no other command within the command library that begins with conf t other than configure terminal. So if you just type in conf t, it cross checks the command library and it runs the command that resembles what we've just typed in. So let's name it hostname router underscore finance. So on the interface to the last network is G001, interface G001. We give it an IP address 192.168.30.1. You include the subnet mask 255.255.255.0, and then we power it on using command no shutdown or no shut. In and it's actually up. So the last interface, that is interface G000 IP add 192.168.20.3 subnet mask 255.255.255.0. then if you issue the command mesh at this time around, it will actually turn green on the interface, or on the cable that is connecting between the two routers. So just issue the command no shut and pop, it's turn green. So what we do next, let's try to test can they actually communicate, and I'll be using the real time. So if you try to send a packet from this PC to this laptop, and if you check on the last setup, it's successful. So you try to send from this PC to the router on the internet, on the network, it's also successful. If you try to send from this PC to the router on the outside network, it will fail, and as you can see, it is failed. That is because our router in the first network do not understand or do not know of the existence of the finance router, the router named finance, within its routing table. Even if you try to send from PC 2 to laptop 3, it will still fail because they do not have an understanding. Actually, the routers do not know or do not have understanding of the existence of the end device on the other network. So in order to fix this, you introduce the routing protocol called IRP. And the command is router RIP, and then you include all the networks or the network addresses that are within the topology or the network infrastructure. So I'll begin with the first network 192.168.10.0, and the final network I'll exit and then copy or actually save the configuration and do the same to the other router. Router RIP, and you include the networks available. Network 192.168.10.0, and the other network address is 20.0, and the final network, that is 30.0. To exit, and then you save your configuration. To that extent, our topology or our network infrastructure should facilitate communication. Dear friend, if you're new to this channel, kindly take a second, hit the subscribe button, turn on the notification bell, and don't forget to leave a comment below. It's very important. So let's try to test the connectivity or the communication between our network devices. So if I try to, first let me delete the previous. So let me try to send a packet from this PC to this router, and you can see it's successful. Again, let me try to send from this PC to this server. It's in progress. It failed, but let's give it some few seconds so that it can update the routing table and try again. It's now successful. Let's try to send again from this PC to the other laptop, in progress. But if we repeat the same, you realize that it is now successful. We can also use simulation method. So let me try to send from PC 2 to server 1 and click play. Let me adjust speed a little bit. And it's also successful. So guys, this marks the end of our video, and thank you for watching. Kindly don't forget to subscribe and leave your comment below.